Hi everyone, my name is Allie Reynolds. I'm with Timmons Group, a GIS consulting firm out of Richmond, Virginia.
Hi, I'm Beth Canada. I work at Orange Water and Sewer Authority, or WASA, in Carrboro, North Carolina.
And today we're going to talk about best practices for implementing the utility network. We're going to start with a little intro on Timmons Group and then talk about the project for planning and implementing a UN. So like I said, I'm with Timmons Group. We are one out of 17 firms in the US certified in the utility network. I personally have the UN certification as well, one of about 20. They don't really release those numbers, but from what we can tell in the US. I also am FME certified. We have many staff who use FME daily, and we are ArcGIS system ready. So all these things contribute to being ready to deploy the utility network to various clients. We've also got a ton of AWS and cloud certifications and other geodatabase across all of our staff. For the UN, we offer a variety of services, and we're going to talk about how we kind of break these into two phases for some clients like OWASA, depending on what's needed. But the primary ones are planning, which is what the OWASA project is currently, data readiness assessments to make sure your data is ready to go to the UN, data cleanup. Sometimes that's done by us, sometimes it's done by our clients. The actual implementation / migration itself to the utility network, that usually includes a systems integrations component. So if you have CityWorks or a billing system or a CCTV solution or hydraulic modeling that integrates with your GIS, we want to make sure all of that continues working. And then training to make sure everyone can maintain their utility networks. We've got related services. Some of these people don't like to consider related, but they're really optional depending on what the client currently has set up. So our architecture enterprise designs, if you already have ArcGIS Enterprise and it's upgraded and deployed in a way that supports the UN, you don't need that service. For most of our clients, we're either doing an upgrade or a full implementation of that to support the UN. We also do cloud migration and managed services contracts. If you don't want to manage your own cloud or on-prem infrastructure, we help do that as well. This is our list of our current utility network clients. So what I want to talk about here is the two phases that we use. You can see phase one is data readiness, UN planning, and data cleanup. We see a lot of clients want to break their UN projects into two phases. Part of that is to make sure they have time to clean their data, and the other is because of budgeting. Break it into 2 fiscal years so they can get the budgeting to support an implementation. So phase two is making sure your ArcGIS Enterprise is installed or implemented. That sometimes ends up in phase one, depends. The actual UN implementation itself, so that's data modeling, the actual migration, testing, all of that stuff, systems integration, and training. So we've got phase one, phase two. These can occur as one project or as two, or however many you want them to occur as. But most of our clients, if they're doing just a UN plan, that's just phase one. All of our implementations, most of our implementations so far have been one project. OWASA is currently in the phase one, but they're also doing ArcGIS Enterprise. So we designed and helped implement their ArcGIS Enterprise architecture along with the data readiness, UN planning, and data cleanup steps. So Beth is going to talk about that project.
Okay, thanks. So WASA, just to back up, we're a water, sewer, and reclaimed water utility for the towns of Carrboro, Chapel Hill, including UNC Chapel Hill. And I was just going to talk about what they've done, which sort of our phase one, and a little bit why we've decided to go the UN route. Ali mentioned we just have currently a single server deployment, and we don't have portal up and running, which is required for the UN model. And we have everything just on the one server. We have CityWorks. We're a big CityWorks user. We've also got just ArcGIS server and image server as well on one machine. So what they've did is make it a multi-machine, multi-deployment, and separate it to install portal. So we're up and running with that, and other machines. Another CityWorks is on its own server now, so that'll help us moving forward. And then there's data readiness assessment. What they do is create different data checks that are part of the data reviewer, which is an extension to ArcMap, to help clean up our data. And it's basically to take our current geometric network and make it more ready for the UN, mainly looking at the connectivity, the topology. There are a whole bunch of, lots of checks that check for like duplicate features, things that are orphaned, things that are dangles, vertices that are too close together, a whole host of things. And then after you run those checks, then the next step, of course, is to clean up, which is a big effort. We don't have a GIS department, it's just me. We do have a couple people like Rick that help edit it, but that's something to definitely take into consideration if you're moving to the UN network. It takes a lot of time to address all of the errors that are found. And then the last part is doing planning. They looked at what we currently have, recommendations for where we'll go. And also integration for the current system. She mentioned a lot of the ones we already have, such as CityWorks, our billing, CCTV, valve inspections. All of these integrate with our GIS. And moving to the UN model, we want to make sure everything still works and integrates. Also our licensing, and then they're also working on what will be our plan 2, a schedule for where we need to go, and an estimate for our budget process to get that funded. Why did we choose the UN? Mainly for us, it was our crews have been asking for years for a solution that will do a true valve isolation trace in the field. They're in the middle of the night, there's a water line break, and they really want to be able to just pull up a web app, say, okay, this is the line that's broken, tell me which valves I need to turn. We were also very interested in the UN ESRI solutions that they have, such as the outage alert to kind of inform our customers, on a public-facing map. We have something in place now, but it's pretty clunky, and we're hoping this will help streamline things. And also, we're just looking forward to a better experience with editing and using in the Pro environment. Currently, of course, you can't edit the geometric network in Pro. Pro just offers more automation. There's better data integrity as well. And hopefully just not quite as tedious. And why do we break it up into a phase 1 and a phase 2? Ellie kind of already covered this. When we talked to other utilities, that was a really common way to do it. The biggest driver probably is the data cleanup effort, allowing time between the 2 phases to have some time to clean up our data ourselves. It just takes time. And we also want to make sure we have the proper IT architecture in place that will allow us to move to the UN. And lastly, just breaking it up, the funding. It helps to break it up over several different fiscal years to help to get it approved. So, but thank you. If anybody has any questions specific, feel free to contact me after the talk. We've been really happy with Timmons, and so far we're really glad that they're on our team. If I had to do this by myself, I would be sunk. It's not easy.
Happy to help. That was a great explanation and covered some points I'm going to talk about here. So why go to the UN? Part of the reason is it's your only option if you're looking to do geometric network type tracing going forward, because ArcMap and geometric network are going away. So the UN is the answer. It does use modern architecture like feature services for editing with branch versioning. It's easy to integrate with some things because of that feature service driven architecture. So if you have anything else like CityWorks, some of those things can become easier to do. A good timing to do utility network, if you're looking at implementing CityWorks, you're going to probably look at your data model anyway, or any other AMS system. So if you're going to do data modeling tasks, maybe consider now we should do the UN prior to that implementation to get it all rolled into one data modeling task. The UN does give increased data fidelity, so you can get much more detailed with the type of objects that you're modeling, like Beth mentioned. Some people right now, you have one point for a lift station. If you want to model all your valves and different things within that, the utility network is a good solution to model all of those items. The different types of associations and containers and those kinds of items get extremely detailed if you're looking for that out of your GIS. That said, if you're happy with your one lift station point, it supports that as well. So whatever suits your needs. Because it is so rule heavy, it keeps you from creating bad data in many ways, because it only lets you snap things together that there's a rule specifically saying you can. So once you have that in place and you've defined all your rules, your editors are more likely to create good data because they can't create bad data that actually snaps. Of course, that's a training item to make sure you don't create features that aren't snapping, but that's all pieces of it. Better analysis capabilities, there's more tracing types. You can use them in more places, like on the web and in the field. More mobile capabilities with those tracing. Field editing is not currently supported by ESRI. Nonetheless, you can do it. There's better modeling if you're into schematics. The diagramming capability with UN is there for you, and collaboration. Because everything is handled through Portal, it becomes easier to share things out to people in your organization, create groups for specific users, and just share services and maps to them. Security is handled by Portal, so whatever you have set up there will be your utility network security. And you get to use ArcGIS Pro, which I know a lot of people still aren't on board with, but it actually is pretty good, especially from an editor's perspective and a data modeling perspective. So time to get on board the ArcGIS Pro train. So that was the carrot. This is the stick. You have to leave ArcMap because it's going away. That's kind of the end sentence there. If you want to do tracing, you need to be in the UN going forward. That is a deprecation cycle for ArcMap. So if you're looking to go to the UN, we have many projects in flight right now. This is an overview of a generic implementation plan. These all get obviously customized to your needs, but first task is discovery. So we really focus on making sure we talk to every group that is using the GIS data to make sure that everyone's needs are taken into account in the future solution. So we came on site with OWASA, we talked to her, we talked to the GIS users, we talked to a couple different departments to make sure that we knew who's using the GIS and what they want the future state to be able to do. So we document that, document infrastructure, different editing workflows, QA workflows, every add-in, extension, integration to the UN or to the current GIS so we can take those into account for the future UN. So number of discovery sessions on this, it always depends. You know, if we're working with a huge company, then that can be days of discovery, or it could be, you know, a couple 2-hour sessions. Test tubes, infrastructure. So this one varies wildly, right, depending on our client. With OWASA, we stood up a whole portal and enterprise implementation. For some people, we just upgrade them from 10.9.1 to 11, or change it from a single machine deployment to a multi-machine deployment to help support performance on the UN. So this one is the most variable of the tasks, and for some of these, we just provide advisory support. So if your IT department doesn't want anyone else touching your stuff, we can say, here's what we think you should do, and then take our hands off and let you guys implement it. So happy to do whatever meets your needs. In most cases, we do the actual implementations. So this is an extremely important step with the UN. The way that the UN works is that if you have data that does not follow the rules of connectivity set up in your UN, it won't build the subnetworks, which are a huge part of the UN, past or at all within that subnetwork. So your data has to be good, and or we have to know what irregular stuff you have in your data to change the rules of the UN. So it's usually both of those things. So we provide data reviewer checks. If you don't have a data reviewer license, we'll just give you a file geodatabase of your errors that describe how you need to fix your data to match the UN. If during discovery or when you're given these, you're like, hey, actually, I do think a system valve should be allowed to be on a hydrant line, then we'll just note that and make a change in the UN. So all of this feeds back into how the UN is deployed, but it's still very important that all of your data get corrected. This task and subsequent task that usually goes on our clients is to clean up the data. We're happy to do that cleanup for you if you want, but in most cases, clients want to maintain their own data. So usually that's a client task. That said, we have seen this slow down and cause schedule upsets in some clients because they didn't anticipate how much they needed to clean up. So that's one of the reasons that doing that 2-phase project is a really good idea. You can give yourself time, you get the errors, you have time to clean them up before you get to the phase 2 where it's important that your data is clean. So this is an overview of all the steps past those first 3 phases. We start with Esri's solution templates. So they have solution templates for water, sewer, storm, electric, telecom, and district energy, which is hot and cold water. Depending on what you're doing, we take that template, and then from multiple workshops, we modify it to meet your particular business needs. This is done by looking at literally every single field and every feature class in your current data. We want to make sure that you know what's in your current data and if you actually are using it. Do you need to bring that into the UN? Are we trying to add a field to the data model? Or are we just adding a field because it was in your old one but no one's actually using that. So we talk through every single field, make sure it's being used, that you still want it that way. Maybe you want to add a domain to it, or add values to an existing domain, or remove values. Sometimes you're not using that material anymore, and you've removed all of your lead pipes. Wouldn't that be nice? So that's an iterative process. We make data model updates to the Esri solution templates, and you get to see those. There's a million Excel files generated and lots of discussions, and then we move on to data migration once you've approved that. So we use Safe Software's FME, or Data Interop extension, if you're more familiar, to do our migrations. And we migrate into that data model that we've customized to fit your needs. This, again, is iterative. We'll populate it, we'll do some QA on it, we'll repopulate it over and over again until we're happy, and then we send it to you to see if you are happy with what's in there. Did all the domain values get over correctly, or is there anything you're not expecting to see? So that comes with a map. So you get a look at the different layers in your map, the fields that are exposed per subtype to make sure your editors are going to have a good editing experience. And then once we're both happy with that, we move on to internal testing. So with that populated utility network, we'll build, or populated asset package, we'll build an actual utility network internally, make sure it meets our standards for functions, and then stand it up in a test enterprise geodatabase in the client environment. So that means that you guys can, at that point, see your data in the UN, even if it doesn't currently, it's not clean yet. Data cleaning can still be going on at this point. You'll see the migrated data stood up, potentially without subnetworks, depending on the data quality, and can provide feedback on that. At that point, we also make sure all of the integrations, so if there's any Python scripts or CityWorks implementations or anything like that that's integrated with the GIS, we would update those in that test enterprise environment, do testing on our side from the UN and CityWorks and whatever other side, and then provide training. So training at this point is averaging out to about 10 to 12 hours of training for all GIS users and admins. And that's training everything from, this is what ArcPro is, this is what a ribbon in ArcPro is, to here's how to change a connectivity rule in your UN once it's been implemented. So across the board, from basically welcome to GIS to here's how to administer a utility network. All of those come with recorded trainings and PowerPoints and a user workflow guide that step-by-step walks you through basically anything you would want to do in a UN. Following that training is when we have client test the environment in that test environment. And once our clients are happy with it, it's time for production deployment and go live. So that starts with an editing freeze. You stop editing your data, you give us the final cut of it, we rerun the entire migration and deployment, and then we deploy that to test and prod again, and finally, testing. Sometimes that's Timmons Group doing testing, sometimes it's the client doing testing, it kind of depends. We're seeing broadly different needs for testing across different organizations. Kind of dependent on size, but also on type of utility. There's just different requirements there, and then finally go live. So high-level phases here, data model customization, migration creation, and then a whole bunch of testing and training. So these next slides just kind of walk through those. You can see on the right here is a UML document that we've automated the creation of for the UN. So at the top, we've got a water line, which is a feature class in the UN. The water main and water service are subtypes. And underneath that, you see asset types for those subtypes. So that's a tool we've created to streamline some documentation. In here, we also create a Excel file that shows exactly where your data is moving from and to. So you'll see like W hydrants is going to the hydrant subtype, the fire hydrant asset type, or your control valves are going to 7 different asset types, or whatever it is. And then every single field within those feature classes also has a sheet that it gets shown where that's going. So you'll see that many times over the course of a project so that you can review that all of your data is migrating correctly. We're also really big into attribute rules. So if you have attribute assistant right now, it's the glow up of that, but we also see it used for a lot of new functions. So if there's anything in your data you feel like you can automate, a slope field, or this thing's intersecting this other thing, I feel like I shouldn't have to fill out this field every single time, we're happy to design attribute rules to automate that for you. We're also heavy users of validation rules. Validation makes everything better with your data, so setting up validation attribute rules with Data Reviewer, if you can get a license for it, and then contingent values, which they've renamed, and I haven't changed my slide. Contingent values are pretty neat. They're in Pro, and they allow you to link multiple fields together so that if you choose, a certain manufacturer, maybe you get just a list of models that go with that manufacturer. We're seeing some clients be really into them, and some clients be like, it's way too much effort to create these lists of different things, so forget it, we'll just QA it later. So those are all optional, but highly recommended, especially depending on what type of utility you're working with. And then editing templates. Within Pro, just outside of the UN, there's a lot of new ways to create features with group templates and preset templates. If you don't know what those are, highly recommend you look at them. They're not like part of the UN, they're just part of Pro, and they streamline editing so much because you can create a ton of features with like one click. If you use the Water Geometric Network Editing and Analysis add-in in ArcMap, it's similar, just a lot easier to set up. So we'll create a bunch of templates for you depending on what you need there. So we do a test migration. You get a bunch of reports on how things migrated, make sure we didn't drop any features, that kind of thing. Just kind of QA stuff and set up those edit templates and any tracing that you want. And then system integration. So I've got CityWorks icon here. Just kind of depends on what you have that needs to be integrated. Like it's integrated at this step. Versioning is set up, all those kinds of things. And then test training and go live. So basically covered that at this point, but we create test scripts, user workflow guides, give training, and then make sure everything's working from our perspective before we set our clients free to test it to their happiness. Finally, go live. So I think that I'm just barely past my time there. Any questions? Anyone currently? Yeah. Let me go back. So, this slide doesn't have it. Okay, well, so EPCOR is water, sewer, non-potable, and it's 3 different networks. Indio is just water. Anchorage is a plan, but it's water and wastewater. Rogers is water and sewer. Alderwood is water and wastewater and treatment plants. So that's like basically not GIS at that point for the treatment plants, but it's related. Pennachuck is water. St. John's is water and sewer and reuse. And then City of Lynchburg is the most interesting one from that perspective because it is water, sewer, and storm, but Lynchburg in Virginia has a combined sewer store system, which means we are creating basically an entirely new data model where we're combining the storm and sewer Esri model into one because their storm and sewer system is so interconnected they couldn't be separate, but they needed a bunch of the asset types from the different ones. Yeah, it's not great. So we're creating a whole new data model for them based on that combined system. So most of these have water and sewer as 2 separate UNs. We considered doing a multi-domain one for Lynchburg, and then after some testing, it didn't make sense for tracing purposes. Did that answer your question? Yeah. Cool. For Disney, I don't know how much I'm allowed to talk about that, but they had electric and water utilities and district energy and a lot of things, compressed air, which we made up one for. They're in the works of still doing a UN implementation, but they've got the data model in place. So we've done everything, basically. Electric and telecom on Disney, too. So the UN was created for electric because it's so much more complex on the water utilities. We have not fully implemented an electric yet. The Disney one is a data model without the network because they did not really have the data for a UN. We converted them from CAD to GIS is where they're at. So we haven't finished an implementation of electric, but we have done the data model for one. But it does work for that, yes. Including like you can get down to like the strand level. I'm not an electric expert, I do water utilities, but it gets extremely detailed so you can set phases and open switches and all of that kind of thing. Yeah.
The model set up, right? Can you ask the
Yeah. It is built basically to do that. So you can do upstream traces and downstream traces. This is all assuming you have correct connectivity and like your sources and sinks set up. But you can do upstream and downstream traces. You can do connected traces, just like what's connected to this. You can do an isolation trace. That uses a component called a network category. So to any type of asset, you can say, this has a network category of isolating. By default in the water system, that's every system valve. But you could say, I want a fire hydrant valve to be isolating and just apply that network category. And then when you run an isolation trace, you can say, use the isolating category, and it will find the 2 nearest valves to close to isolate that area. You can set that up. The trace parameters themselves are like very extensive, so you can customize that a lot. In order to do the calculation of how far upstream, it's called a function within a trace, and then it will calculate for you like total miles of pipe upstream or however long the trace goes to, whatever you have it set to stop at. Yeah, it can return all that. You can also have it like go until you find a pipe that's over 100 feet, and then it'll just keep going until it finds one that matches that parameter, as long as it is in the subnetwork or whatever kind of trace you're running. Any other questions? Go for it.
If someone was attempting to roll their own utility network, the Esri documentation, does it get you very far, or in your opinion?
It took me 2 years to feel like I knew what I was doing at all with the UN. I think that if your current data model is the LGIM that hasn't been modified, you might have an okay time. Otherwise, it is not a straightforward process. I think a lot of their documentation was sufficient to explain what a concept was without how to apply that concept. So I think their training is all right as a starting point, like the instructor-led stuff. But I think you have to get your hands dirty to understand it. And even then, like, if you can use your data to do that, even better, because you'll actually understand, like, why is it stopping here? Oh, I have a valve that's closed, or something like that. But yeah, it's not straightforward. Any other questions? Okay. Good timing, guys. Thanks, y'all.